Much has been said about particle contamination and its effect on component longevity. However, in lubricants, water is the second most destructive contaminant behind particles. It causes issues such as rust, decreased load carrying capacity, and permanent degradation of the lubricant. In previous lessons we memorized that water can exist in oil in three phases: dissolved, emulsified, and free water. The first state is known as dissolved water. This you can compare to moisture in the air on a humid day. Too small to see. Thereby, depending on the temperature and age of the oil, an oil can contain a significant concentration of dissolved water, with no visible indication of its presence. The point at which an oil contains the maximum amount of dissolved water is termed the saturation point. At that point, the water is suspended in the oil, in microscopic droplets, known as an emulsion. This can be compared with fog on a cool, spring day. The saturation point has been exceeded, resulting in a suspension of small droplets of moisture, also referred to as haze. When sufficient water exists, or when the oil has adequate demulsibility, free water will collect. Because water is typically heavier than oil, it settles below the oil, at the bottom of sumps and reservoirs. Because the effects of free and emulsified water are more harmful compared to dissolved water, a general rule of thumb is to ensure that moisture levels remain well below the saturation point. For most in-service oils, this means 100 to 300 parts per million, or less, depending on the effects of water on a lubricant. Not only does water have a direct harmful effect on machine components, but it also plays a direct role in the aging rate of lubricating oils. Water will affect the oil's base stock, encouraging oxidation, viscosity and foaming. It's also a generator of other contaminants in the oil, such as waxes, suspensions, etc. Additionally, certain additives are hydrolyzed by water, resulting additive mortality and the formation of acidic byproducts. Summarizing, water encourages rust and corrosion and will cause increased wear. Reducing water contamination in oil. There are a few ways to mitigate water contamination. Of course, you'll have to recognize its and restrict its ingression. Thereafter, analyze its state and concentration, and then remove it as quickly as possible. Controlling water entrance. Let's have a quick look at some small steps, which will contribute to mitigating the water contamination. 1. Prevent washdown water from entering vents and reservoir covers. 2. Properly install and seal covers and hatches. 3. Install desiccant air breathers or vapor extractors. 4. Prevent water from entering new oil by storing drums indoors. If they must be stored outdoors, keep them under a shed or tarp, or store them on their sides with the bungs horizontal at the 9 o'clock positions. 5. Periodically drain water from low points in system. 6. Environmental condensation will always occur in the tank, because of system breathing. Tanks should be stainless steel or coated with an oil-resistant paint. Removing water from oil. Once the sources of water contamination have been controlled to the extent possible, there are several methods to remove water from oil. Methods that can be used successfully for different applications include settling, heat, chemical demiers, filter, coalescers, centrifuges, vacuum dehydrators and electrostatic treatment. Basic measures to address water ingression include the use of desiccant breathers, improved seal technology, and training maintenance personnel to avoid direct contact with water on shaft seals and breathers. Water is a major cause of lubricant failure, component failure, and poor machine reliability. Like all contaminants, it is important not only to recognize its presence, but also to take steps to control or eliminate the water ingression. If possible, water levels in all equipment should be kept below the saturation limit, with every effort made to keep moisture levels as low as possible.